Hello, this is Craig McFeeters, author of LuckGrib. Today I want to demonstrate some of the customization that is available in the Mac product. The Mac product for a long time has been able to be customized to draw a very wide range of GRIB data or weather data. LuckGrib can be used to download all kinds of weather data from a variety of weather models. This demonstration will be running version 3.2 of the Mac product. I want this video to be task-oriented. The scenario will be that I want to download some weather data which the application does not currently recognize or support. While you may not want to do this on your own, there are some techniques used in this demonstration which you can use yourself to customize the draw styles however you want. So the first thing to do will be to download some weather data. In version 3.2 of the application, there are several new models which allow you to download all the parameters for two models which have not been available previously. For a long time, we've been able to download all the parameters for the GFS model using this model served by NOAA method. In version 3.2, I've added two new models into the regional area. And now you can download all the parameters, all the weather parameters for the NAM continental USA and the HRR, the high resolution rapid refresh model. For this demonstration, I'll be using the full access to HRR method to download some data. Now, the HRR model has a lot of parameters. And as you go in here, you may be interested in looking at some of them. There's a lot of parameters which are not supported on the LuckGrib server. So if you want these parameters, you can get them directly through this new method. For this demonstration, what I want to do is to support or download data for this one, a simulated satellite water vapor. This is a simulated GOES satellite. GOES is the Geostationary Operational Environmental Satellite, which the US Weather Service runs. So let's do that. So we'll close the Explorer, we'll download a new request. We'll go in and grab the model. It's in regional North America. Model served by NOAA, and I'll use the HRR model. And I'll download the simulated data water vapor. And what I want is, I'll take all the forecasts at full resolution. Oh, it's a big file. I'll do every 3 hours, 70 megabytes, that's a bit smaller. And I'll call it water. I'll call it HRR water vapor. Okay, and I'll download it. This method of downloading data is a little slower than the data which we get through the cluster directly. So we'll have a short pause here while this completes. Okay, there we go. That took a little while, but now we have all the weather data we just asked for. Now you'll notice that there's presets available for pressure, pressure and wind, because we did also request pressure and wind data as well as the satellite data. But there's nothing here which indicates the ability to see the satellite data. Now if you look at the file list, it's a little yellow dot beside the file, which indicates there's something going on here. So we open up the file, and we see pressure and wind data, and it looks like this SBT123 parameter is the parameter which is downloaded for the simulated GOES satellite water vapor, and is an unbound parameter. So what that's telling you is that the application doesn't recognize what type of parameter this is. So the first thing to do will be to teach it. So we'll go into the field. So the thing to do first is to create field which represents this parameter. And when we do that, you can tell the field what kind of data it is. So the first thing to do will be to add a field. The parameter is the one shown in the first window, SBT123 tab. And now we see that this is a parameter the program recognizes, and it shows that the name of it, which is simulated brightness temperature for a GOES 12 channel 3. And we'll come back to that in a little while. So the kind of field, there's different types the fields can take on. In this case, it's simply scalar data. Every value in the file represents a magnitude. In this case, it'll be a temperature. So here we have, so now we have a new field that's just been introduced to the list of fields. And while we're here, we can also give it, well, a little more information. So this category, we'll call this the GOES satellite water vapor. And that's good for now. So at this point, as we move the cursor around, we now see that there is information being shown in the top right-hand corner of the screen. So GOES satellite water vapor is showing you temperatures as we move the cursor around. So that's nice. So now if you wanted to know what the temperature of this information was at some point, you could move your cursor there, and now you know. However, that's not really what you want. You want to see an image. But the first task is done. Now normally when you download new data from that model, which we downloaded from, there will already be a field created. Many of the fields for a wide variety of weather parameters have support in LuckGrib, but very rarely you'll download a file which doesn't have support yet. So that's how you do that. Second step will be to start to create some draw information. So now we see there's still 4 parameters. There's no more unbound fields, but there is an undrawn field. And again, this is SBT123 is the one which is shown. So what we want to do is create a color map or color image called a scalar image. So we'll add a scalar image algorithm or draw style. The field parameter is SBT123, the parameter we saw earlier. So now we have a new algorithm has been added to the list. And if we go over here, this is where we'll spend a bunch of time. We need to create the color map for this new field. So let's figure this out a little bit. So we have temperatures across the whole US, and we want to create mappings between the values, the temperature values and colors. Normally to do this, you have to know quite a lot about the information which is being represented. It's useful to find out how other people have shown this field. So we'll bring up the GRIB Explorer, and I'll show you where you can find some of that. So in this case, we'll go back to, that was the HER model, this one. And we'll visit the website. Okay, here's the LuckGrib website for HER. And this version of the model, which is the NOAA direct download method, basically references the normal, the HER model on a cluster, which is here. And if you read this, it has a reference to the official documentation. And now we have, well, I've been here before, so I know what to do now. If you follow along on the left-hand side, there's a link to HER Con US Hourly. If you go in there, then this shows you all the fields that are available in this model, along with some examples of how you view them. So there's this GOES West and East, and we'll look at that soon. So we'll pick one of these pick the 1 hour forecast, click there, and hey, look, there we go. So we have a color image now. So this is a target of what I want my image to look like. And the important part here is that at the bottom of this image is an example color table. So what I'll do is I'll just expand that a little bit, make it fairly big, put it at the bottom. And now what I'll do is I'll go back to LuckGrib, exit full screen window mode. And what I want to do is get this window on top of, yeah, here we go, it's the same screen. And I'll make the window a little shorter. So yeah, now I can see both LuckGrib and this color map. So what I want to do is put this color map into LuckGrib. And there's a few steps involved. It's a little tedious, but basically you just persevere and go through some steps. And the first thing to do would be to look at this color map a little bit. I'll use this little zoom feature in the accessibility part of macOS to zoom in. So we have values on the right which are negative, and on the left they're positive. So it's a little backwards. I'll first show you how to start to edit the color table, and then we'll pick out some of these colors and try and reproduce this one. So the first thing to do will be to open up the color table editor. So we'll go back to the Draw Styles editor, we'll tear it off. Actually, why don't we just take a look at an existing color map first to get a feel for it. So we'll look at the wind speed. Let's see if we can find good. Well, that's fine. Somewhere here. So we'll open up the color map for wind speed. And here's the color map for wind speed. So we have a bunch of values and colors. And in between the colors, there are interpolations. So something new in version 3.2 is this button, this row of buttons, sorry, column of buttons. So at the moment, this is saying that this color defined at 0 smoothly maps. It's a ramp from 0 to 5. And if we change that to make it rather than a ramp, it's a constant value now. So this color is now holding constant between 0 and 5. And if we change a bunch of these, we'll just see what happens. Sometimes as you look around the web, you'll see different color images for weather parameters, and sometimes they use constant colors, like you have pools of colors now, which is what you see. So when you see a boundary between two adjacent colors, that shows you that what the value is there. It's similar to a contour. I tend to prefer smooth blends. So we'll undo all these, undo. So we'll keep track of that. That will be useful for the color map we want to define for satellite images, because this first portion of the image is constant color, and the last portion is also constant. Okay, so that's an example. So we want to find values and colors. So what we'll do, we'll go back to satellite data. And at the moment, it's an empty table. So we'll start by doing a simple example. So we'll have two rows. I pushed plus twice, and I'm changing the top one to 10. So now we're going to define a mapping between 0 and 10 degrees Fahrenheit. And actually what I'll do is I'll turn off these draw styles. I'll turn off contours, turn off arrows. All we have turned on now is this simulated brightness, the satellite data. So we'll go back. We have two values at 0, which is why we're seeing black. And I want to pick a color. So I'm just going to do a simple example. And let's see, I'll do fully saturated red, and then I'll do this other one. You can drag and drop within this window very easily. You just pick a color and drag it somewhere else. Or alternatively, you can pick a color and drag it onto this area below, which is a way of saving it for later. If you want, you can drag between the colors And well, you can drag and drop all over. I'll show you some more of that. So I'll go back to this color, edit it to make it, I don't know, blue. And so what we have now is, I want to show you how interpolation works. So there's two colors defined, red and blue. And in the color map being generated, you see red, blue, and purple in the middle. And you may be wondering, like, why is there purple? I only define blue and red. And what's happening is that it's interpolating colors on this wheel. So we have one value of blue over here. And then the red value is over there. And as it interpolates between these two values, you have to imagine the rotation also interpolates. So as it goes from red to blue, purple is in the middle. So it goes through purple between red and blue. And you can see that if we change the red to like yellow, if we go far enough over, it'll switch between interpolating one way around or the other way around. So as I move this bottom color over towards blue from the green side, the color table shows green. So now there's green in the middle. And if I change this over here a little bit, it'll flip between the green, between interpolating one way around or the other way around. So now it has purple in the middle. If I go over a little bit, it has green in the middle again. So that's something we have to be careful of. So if, for example, we want to interpolate between yellow and blue, which are almost on the opposite sides of the color wheel, we don't really want to go through green or through purple between these two values. So we'll figure that out as well. So the first thing to do, well, let's solve that problem. That's kind of the crux of what we have to do here. So we set one side, well, actually we'll pick up colors. So this editor, color editor, has the ability to pick colors. There's a little eyedropper here. So click on the eyedropper, and then we'll pick up the yellow. So I want the blue. The lower value is blue. So here is blue. Now when you do that, the cursor goes away. So I move up the top of the window and click somewhere, and it brings back the cursor. So you bring back the window again, and I'll edit this top color, and this is the yellow. So I'll pick up the yellow. It's around 5. It's around here somewhere. So there's a yellow. Again, click somewhere on the screen to bring back the cursor. Bring up the editor. So there's the blue and yellow. And these should be the colors we see in the bottom of this, in this example here. So it's going through green between blue and yellow. So I want to change that. And the way to do that will be to direct the interpolation a little more closely. So let's add a new value. We'll put this middle one at 5. And what I'll do is I'll pick up the color in the middle of these two. So it's going between minus 25 and yellow's at 5, which is a span of 30. Half of that is 15. So I want around minus 10 is the middle. So it's like a gray in the middle. Okay, click somewhere, bring back the cursor, open up the window again. So that's getting better. So the blue, or I guess the yellow to gray is doing pretty well, but the gray to blue still has green in between. So again, we'll bring up one more value. I'll put that below. So I want this one to be, I want to now force the interpolation from blue to this color. And I'll drag and drop this gray to the lower field. And now we'll edit this one. And kind of, so at the moment the yellow is here, it's interpolating between this value, which is still on the yellow side. So that'll be an interpolation from this point over to here. And I want the blue is over here, and I want that to interpolate to a similar point in the middle over here somewhere. So I'll do that. So there's that dark yellow. I'll move that over to the blue side. Okay, the color table looks pretty good now. There's a bit of a gap here, which I don't like. So you can fix that by bringing these two values closer together. Make that 4.9 and or 4.99. And And yeah, that's pretty good. That's decent enough for now. Close enough for our purposes. So let's just continue. Let's just build the table now. So this blue isn't at 0. It should be at minus 25. And the middle point is 15 above that, so that's minus 10. And I'll put that one just a little bit above it. 10.1. Oops. Minus 9.9. And then the yellow is at 5. Okay, so below the blue we have a white at 50, black, and then the very lowest one. So we have 3 more below it. The very lowest one is minus 120. Oops, 110. This one is going to be minus 80. And we'll put this, it will be a white at minus 50. So let's do the very bottom white first. We'll grab this constant color. There it is. Click, bring back the window. And then we'll do the minus 80. It's going to be the black. Actually, it's already black. I'll drag this white up to the black and edit it so it goes to full black. And then the minus 50 is full white. And again, I just drag this white up there. And yeah, now we're looking pretty good. We're starting to look like we have an image here. Interesting. So there's some yellow here. We haven't defined yellow yet. So there's more of a table we have to continue with. So this bottom, it goes from minus 110 to 80. That should be constant. So now we have a constant color at the bottom. It goes from black to white, white to blue, and it's showing a little purple there. Although I think for now that's probably going to be good enough. And we'll define some more colors on top of this one. So it goes from yellow at 5. The next color looks like it's something around 25, 25 to 40, let's say. So I'll add 2 more. The very top one is 40, and this one's around 25. The 25 value looks like it's a red, somewhere like that. Click somewhere, bring back the cursor, open up the editor again, and the very top value is a black. And well, I'll copy the red up to the black, and I'll edit it so its brightness falls down to black. And by doing that, I maintain the hue, so there's no rotation of these colors. If you do a lot of this, you'll pick that up. It's a trick. Okay, so that looks pretty good. Yellow to red, red to black, and then anything beyond black will pick up, or anything beyond 40 will pick up the very latest color. So this color table is defined up to 55, but these all seem to be pretty constant black. So anything beyond 40 in our table will use the black, and it's constant. So yeah, that looks pretty good. So this color map, if you compare that to the one at the bottom of the screen, we have constant white, black to white, same white to blue, blue through kind of a gray to yellow, yellow to red, red to black. Perfect. So yeah, there we go. We have a color table set up. And I wasn't sure what the units weren't defined on this example, and they defaulted to Fahrenheit. And if I change that to Celsius, oh, actually that looks reasonable too. I'm not sure which one it is. So let's go back to the. Okay, so this is the water vapor image. If I compare that one to our table, let's do that again. There's the example, the NOAA version of this image. It's a different data set, different time, so you can't compare directly, but the general colors, you have blues and some grays there. So yeah, it does look like the color table should be set for Celsius, not Fahrenheit. The Fahrenheit image for color vapor doesn't seem like that's a good match. So it appears that the color table on the NOAA site was using Celsius. Cool. So we're almost done. So we can animate between these, and we can see water vapor. So now we have simulated satellite water vapor support in LuckGrib. So let's continue a little bit more. I don't see that draw style in this list of presets yet, so let's add that. So these, I have turned on the proper algorithm. I'll create a new style set, and I'll call it simulated water vapor. And this is Geo's West. So now in this file, if you download this data again, you have a selection of pressure, the new color image, wind pressure, wind, and so on. There we go. Pretty cool. So this technique can be used to create any kind of draw style. So we've just created a scalar image, but if you wanted to create draw styles for arrows or contours or streamlines, you choose to create a different algorithm and set it up. And let's do one. This video is becoming kind of long, but I want to show one more thing. So what I'll do is I'll download some more data. I saw that there was water vapor support as well as the infrared. So let's download some data for the other satellite parameter. And then I'll show you one more thing. So new request, same model from NOAA. This time I'll turn off pressure of wind. Let's do all of these. And I'll do every 3 hours again. And download. And this will take a little while again. So I'll pause the video and I'll come back. Okay, here's the file done. Let's continue a little bit further here. Okay, so now we have a bunch of new data. And let's go back to Safari briefly. So here's the model. And what I want to do is back up to this list again, and we'll look at one more of these. So we just saw water vapor, and here's the infrared image example. And it looks very different. You have a bunch of reds and blues, but the color table is the very same as the previous one. So it goes from -110 on the right to 55 on the left. Same kind of ramp between yellow and red and blue and white and so on, which is nice. So the color table we just made is also the same color table that can be used for the infrared channel as well. So let's do that. So we have that data now. And again, we'll go back to the file. In this example, I'll be creating fields manually. If you do this yourself using LuckGrib, the released version of LuckGrib, you'll find the fields already created. But there are 3 parameters which are unbound, so let's just do that quickly. SBT 113, and it's a scalar image, sorry, a scalar value. And we'll do another one, SBT 114. Again, it's a scalar. And the last unbound value is SBT 125.24, sorry. And it's a scalar as well. Okay, so now there's no more unbound fields. Next step will be to create new draw settings. So I'll do a scalar image for SBT113. There we go. And I'll do another scalar image for SBT114. Cool. And last one, SBT124. Okay. So let's go back to our color editor, or our presets editor, or draw styles editor. So here's the one we already have defined. So what I want to do is take this color map and save it, or I want to reuse this color map. So I'll drag it down to this the presets area here, and then close the window. Oh, actually, before we do that, let's change this opacity to around 60%. Yeah, it looks a little better. I'll save it. I'll drag it down again. So I want this one. Turn that on. There's nothing defined for this yet, but I'll drag this up. And yeah, there we go. And we'll do it again for this next one. Turn that guy on. And use the same color map. There we go. Oh, that's interesting. It doesn't look good. Let's come back to that. So let's change the unit, see if that helps. There we go. So the unit wasn't defined. Should be Celsius. Yeah. Celsius. Let's do the last one. Turn that on. And we'll drag color map up. Change it to Celsius. Change opacity to 60. Already is. There we go. Okay, so this one more thing I want to do is fix up this text being displayed. The text at the moment is pretty verbose. So there are two satellites, 11 and 12, and two channels for each of them, 3 and 4. And if you Google, for example, GOES 12 channel 4, you'll find a bunch of articles which to talk about that. And after a little digging, you'll see that the GOES 11 and 12, different name for those will be GOES East and West, with 11 being West. And channel 3 is water vapor, channel 4 is long wave radiation. So let's use that information to improve the text being shown. So we can do that by editing the fields of all these parameters. So GOES 11, so I want this category to be GOES West, and channel 3 is water vapor. And this is GOES 11 again, which is West, and channel 4 is long wave. And here we have GOES 11 or 12. So that's East. Channel 3 is water vapor. And this one is 12 again. East and long wave. Okay, let's try that. So now, yeah, that's better. Moving the cursor around, we see two categories of information with two parameters each, long wave and water vapor. And the last thing I want to do is create these draw style sets so I can click on a value in this area to visualize the data. So let's just do that. I'll turn on this top algorithm, this top draw style. And this one's channel 12, sorry, GOES 12, channel 4. And I want this preset. 12 is East. Channel 4 is long wave. And I won't do all these, it's kind of tedious. But yeah, you see, so now if I click on this preset, I see that data. So I think that's pretty much, I think we're done at this point. I can create more of these presets by clicking the combination you like and giving it a new name. You get the idea. We're almost done. So we spent half an hour teaching LuckGrib how to view this data. So say you're in a small community of people who want to share this information now, you can do that easily. So if you go to LuckGrib preferences, the application preferences, there's different areas here, but the draw settings area will allow you to export the draw settings. So we'll call it new, and we'll put it on the desktop. So this file contains all of the draw settings and the presets and the fields, everything you need, in everything that's in the current state of this version of the application. You can reset these settings at any time to be the settings that I ship with the application, but if you customize them, you can download your set. So now if you give that file to somebody else, they can open up their own preferences and import those settings, and by doing that they'll have full support for this satellite data as well. And you can also take that file and copy it to your your iPad or your iPhone. If you share it using AirDrop, as you drop the file onto your iOS device, it'll launch the application and automatically import these draw settings onto your iPad or iPhone, and that way you'll be able to download the data from your iPhone or iPad and also have the same draw settings. So once you've done this work once, you can share this work with other people or other devices very easily. Pretty cool. So I think with that, I'll wrap this up. Yeah, that's LuckGrib. It's very customizable. I'm able to display information for pretty much any GRIB data that's available on the net. You can use this app to view it. So, and of course all the weather data is, all the data that sailors need is already supported pretty much. But if you don't like the way that some field is being drawn, you may want to change the color map for wind, for instance. You can do it very easily and then share those customizations with other people. So yeah, let me know what you think. Cheers.